Hi guys, welcome back to another video of me teaching. And today I have the 2000 IMO question 2 for you guys. And why don't we just get into the question. So, this question says that A, B, and C are positive and A times B times C is equal to 1. Show that A minus 1 plus 1 over B times B minus 1 times 1 over C times C minus 1 plus 1 over A is less than or equal to 1. So, similar to the last video, we have this condition that ABC is equal to 1, so we can do the same substitution we have done in the last video. But unlike the last video, we are not going to use the Cauchy inequality this time. Super sad. So, again, I'm going to just let A to be x over y, B to be y over z, and C to be z over x. And just a note that x, y, and z are all positive. Okay, so it will be A, which is x over y, minus 1 plus 1 over b, which is the reciprocal of b, which is z over y, times, b minus 1 plus the reciprocal of c, and the same logic for the last bracket, it will be z over x minus 1 plus y over x. Okay, so doesn't this look very ugly? Well, yes. So we're going to make all of these brackets into just one fraction. So it will be, of course, the denominator is y. You can add this up, x plus z. And you can think of the 1 as y over y. So you minus the y on the top. And then you multiply by, the bottom is z. Same logic, y plus x minus z times x, z plus y minus x. Okay, and we have to prove that this is less than or equal to 1. So now I'm going to multiply the x, y, z to the right hand side because we don't like fractions. So we'll get x plus z minus y times y plus x minus z times z plus y minus x. And we have to prove that this is less than or equal to x, y, z. So if x, y, and z are all positive, then x times y times z is definitely positive, right? So if we want to prove something is less than a positive number, then don't we want this thing to be negative? Now, I'm not saying it is negative, but that would just be one of our cases. So, shouldn't case 1 just be, we assume any random one is negative and see what happens. So, I'm going to write them back up here. So, case 1 is that, without loss of generality, we can assume that just the first bracket to be less than 0. So, x plus z minus y is less than 0. So, we'll get y is greater than x plus z. So, we know if this is negative, then we have y minus z plus x, which, using this inequality, is positive. Same logic for this bracket, using this inequality, is positive. Negative times positive is negative. So negative is obviously less than positive. So this case works. Well, now, what will case 2 be? Well, you can test this out yourselves. But if any one of these brackets are negative, the rest have to be positive. So, what should case 2 be then? Well, shouldn't it be all of them being positive? Well, yes. So, but how do we solve it when all of them are positive? Well, think of it like this. If we have an equation or a simultaneous equation, x minus y is equal to a and x plus y is equal to b, then how do we find x and how do we find y? Well, this is probably just some primary school stuff, or maybe like year 7. Then you'll get x is equal to a plus b over 2, and y will be b minus a over 2. Okay, but how is this relevant to us proving that this is less than or equal to x, y, z? Well, it actually is, because now I'm going to use the AMGM formula. So I'm going to let each one of these brackets to be a different variable, say m and p respectively, and then if we figure out x, y, and z and we plug it into the right hand side, then it'll be some fraction is greater than or equal to some product, which is the AMGM formula, right? So that's exactly what we're going to do. I'm going to rub this out. So I'm going to let x plus z minus y is equal to m, y plus x minus z to be n, z plus y minus x to be p. Now, just note m and p are all positive because case 2 assumes that all of these are positive. So now we can easily figure out x, y, and z. So we'll get x is, just add the first 2 equations up. So you get m plus n over 2. Similarly for y, add the last 2 equations up. So we'll get n plus p over 2. And for z, just add the first and third equations up. So we'll get m plus p over 2. So then we have to prove that m times n times p is less than or equal to x, y, z, which if we substitute it all in will be and then the bottom is 2 times 2 times 2. Okay. Well, now I'm going to split this up and use the AMGM formula. So I'm going to split it up like this. 1 fraction, 2 fraction, 3 fraction. So first dealing with the first fraction, m plus n over 2. Using the AMGM formula, this is greater than or equal to square root of mn. Similarly for the others, n plus p over 2 greater than or equal to square root of np, and m plus p over 2 greater than or equal to square root of mp. Now, if we multiply the left hand side up, we'll get the left hand side is greater than or equal to, and just a note, the left hand side is this, is greater than or equal to square root of, if you multiply this up, you'll see that it will be m squared, n squared, p squared. So they all cancel out. So it will just be m times n times p. And this is actually equal to this. So we have proved that this is greater than or equal to m and p. So case 2 is correct. So we have successfully proved that this is less than or equal to 1, and we have successfully finished an IMO question. Well, thank you guys so much for watching, and if you enjoyed my video and you want more content like this, please consider liking and subscribing. If you want to master something, teach it.